Hi, pre-calculus. Let's do a recap of quadratic equations and all the different forms they might possibly be in. Okay, so the first form is called vertex form. When you're in this form, the vertex is very easy to see. Okay, we just have to make sure that we do the opposite there of that h value. H comma k is the vertex. This a value out in front tells us a couple of things. Okay, it tells us the vertical stretch or shrink. Okay, but it also tells us how the graph opens, if it opens up or down. So the a value could be negative or positive, but could also have a number out in front. Okay, whenever you're doing these different forms of quadratics, one thing is very easy. Okay, so for vertex form, the vertex is right there. Okay, you just look to notice it. Axis of symmetry would be x equals, okay, whatever that h value is right there. And that's the same for all the forms. Whatever the x value is of the vertex is your axis of symmetry. To calculate a y-intercept, this one might take a little bit more work. We're going to go ahead and let the x value equal 0, and then you have to calculate the y-intercept. Okay, so let's take a look at an example here. I have a quadratic equation. To state the vertex, all we're simply going to do here is look at the h and k value, but I have to make sure that I make it be the opposite, -2, 3. The axis of symmetry is x equals, okay, whatever this x number is, -2. So this would be a parabola opening down, since it's a negative. I've got a vertex right there. The axis of symmetry, of course, would go straight through the vertex, and it's going to be a vux, a vertical line. Okay. To find the y-intercept, we're going to go ahead and let the x value equal 0. So y equals -0 plus 2 squared plus 3. Let's go ahead and calculate this. 2 times 2 is 4. -4 plus 3, that gives us -1. Okay, but how do we write intercepts? That's right, we write them as a point. 0, -1. Okay, we're always going to write intercepts as points. Okay, let's take a look at the second form. The second form is called intercept form. Okay, this could also be thought of as factored form. Okay, sometimes I'm going to ask you to find the x-intercepts, and you're going to have to put it in factored form. Okay, so here's what it's going to look like. The a value would be factored out, x minus p, x minus q. So the x-intercepts are p, 0, and q, 0. If I happen to have a parabola, okay, maybe opening up like this, and we have a couple x-intercepts, 1, 2, 3. What if we have one at -4? 1, 2, 3, 4, 5, 6. Okay, if those are the two intercepts, the axis of symmetry, of course, would be going right down the middle of them. Okay, something like this, right down the middle. Okay, so we're going to ask you, what is -4 plus 6 divided by 2? And that would be how you find your axis of symmetry. 6 minus 4 is 2. 2 divided by 2 should be a 1. Okay, you could also do this by counting 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 to the left. Okay, so when they say axis of symmetry, you could find the average of the zeros of the x-intercepts to find that center point. Okay, in factored form, x-intercepts are clearly the easiest. How do you find a y-intercept? Well, you're going to have to go ahead and let the x value equal 0 and calculate it again. Okay, so here's an example. This equation is already in factored form or intercept form. So the x-intercepts are -2, 0 and 4, 0. Okay. The axis of symmetry. Okay, what you could do is graph this. We have a parabola opening down at -2, 1, 2, 3, 4. Okay, and where would the center of that parabola be? Where would the vertex be? We could average them. 4 plus -2 is 2. Divided by 2, once again we get a 1. Okay, so the vertex right there would be x equals 1. Okay. How do you find a y-intercept? You're going to let the x equal 0. Y equals -5, 0 plus 2, 0 minus 4, okay? And what do you get for the y value? -5 times 2 times -4, negative is positive, so the y-intercept is, don't forget to say 0, 40. Okay, the last form that we studied is called standard form. Okay, standard form is when you have all the terms multiplied out and you have your A, B, C values, okay, which are helpful. Vertex requires a little bit more calculating. We have to use the H and K formulas, okay, or, okay, what we can also do is complete the square. You can complete the square and that will help you find the vertex as well, okay. Axis of symmetry is x equals that x value. All right, so what's easy about standard form? Well, there's always going to be one easy thing, right? The y-intercept is the easy thing when you're in standard form. The obvious thing here, okay, you could just take a look at the c value to find the y-intercept. Okay, so one thing is easy based on the form that you're in. Here's an example of a parabola. Let's go ahead and find the vertex. I'll use the H and K formulas. H is equal to -b over 2a. 8 divided by 4 is 2. K is c minus b squared, which is -8 divided by 4a. Negative cancels. 4 times 2 is 8, so one of the 8's will cancel. 5 minus 8 gives us -3. So the vertex is the point, 2, -3. Okay, a vertex is also a point. So you're going to want to make sure you write it as h, k. Axis of symmetry, well, that's always just going to be a vertical line. X equals whatever that x value is of your vertex. Okay, how about the y-intercept? Oh, y-intercept is super easy. I could plug in a 0, plug in 0 for x, okay, and then what happens? 0, 0, 0, you just get the 5. Okay, so y-intercept in standard form is just your c value. Okay, go ahead and turn to the second page for some other things we studied with quadratics. Okay, the first one is the discriminant. The discriminant is b squared minus 4ac. That's the formula for it. Okay, and what does this help us do? It helps us determine how many intercepts there are. Okay, so for example, if b squared minus 4ac is equal to 0, that means that there's only one x-intercept. So it's going to look one of two ways. Okay, maybe it's a parabola opening up and it has its vertex right on the x-axis, or it's a parabola opening down with its vertex right on the x-axis. Okay, it's just going to have one x-intercept. If you do the discriminant calculation, okay, and we get greater than 0, so what that means is you get something that's positive. Okay, then there are going to be two x-intercepts. And what's that going to look like? A parabola opening up or down, however you want to do it, but there's going to be two distinct touches on the x-axis. Two x-intercepts. If you do the discriminant, okay, and you get a calculation that ends up being less than 0, meaning negative, then there are no x-intercepts. Okay, there's still a parabola, and there's still a quadratic equation. The only thing is the parabola might be all the way up here, not touching the x-axis, or it could be opening down. Oh, that was close. Not touching the x-axis. Make sure that's a little higher. That picture looks really bad on the screen. I'm going to draw it again. Not touching, move it down. There we go. Now it looks better. Calculate the discriminant. Okay, so I notice that this is a parabola opening up. The discriminant calculation is b squared minus 4ac. Okay, so the discriminant is 36 minus 32. Sometimes I don't know that number easily, okay, but I know that it's going to come out to be a positive, and that's all I really need to know. So when you get a positive discriminant, okay, what that means is that there are two x-intercepts. That means this parabola touches the x-axis 2 times. Okay? Find them. Oh, sure, I'd love to. Okay? How do you find an x-intercept? We're going to let the y equal 0. Let the y equal 0, and it looks like we're going to go ahead and factor. We have x times x in the beginning. How do you make an 8? I think it's going to be a 4 and a 2. Both of them are going to be negative to add to negative 6. So the x-intercepts are 4, 0, and 2, 0. Okay, if the discriminant came out to be negative, then there are no x-intercepts. I wouldn't bother trying to find them. The discriminant helps you determine how much time should you spend trying to find something. If they don't have any, and they don't exist, don't waste your time trying to find them. Does that make sense? How about a max-min point? Okay, this is super easy here. It's just about a parabola opening up or down. So we're going to take a look at this a value. If the a value is less than 0, okay, so that means we have a negative leading coefficient. That means the parabola opens down. When the parabola opens down, that means it has a maximum. That's all you have to do is draw a little picture of a parabola, and then you'll know max or min. If the a value is greater than 0, so we've got a leading coefficient that is positive, the parabola opens up. And when a parabola opens up, okay, it always has a minimum value. So really all you have to do is draw a little doodle, and then you'll be able to answer this question easily. Okay, take a look at this equation here. X squared minus 6x plus 8. Does this one have a maximum or a minimum? Well, the leading coefficient is positive. That means the parabola is going to be opening up. An opening up parabola has a minimum. Okay, that's all you have to do there. Oh, find it? Sure, I'd love to find it. How do you find a vertex? Okay, a max or min is a vertex. I will do h and k calculations. H is equal to negative b over 2a. So that's 3. And k is c minus b squared. That's negative 6 times negative 6 over 4a. The negatives will cancel. Cancel the 6 by 2. That gives me a 3. Cancel this 6 by 2. Gives me a 3. 8 minus 9 is negative 1. So the vertex is the point 3, comma, negative 1. All right, the last thing that we studied, okay, was when you have a function equal a value. Okay, so for example here I have a parabola, and then we've got y equals number. So this would be a parabola since it's a quadratic, and y equals number means it's going to be a horizontal line. The horizontal line may touch no times, may touch 2 times, it might touch just 1 time. It cannot touch a parabola 3 times. So what you do is you graph the parabola and you graph the horizontal. We set f of x equal to number. You move all the terms to one side, okay? Then you have equals to 0. And then, of course, we're going to factor to solve. Okay, so here's an example of one. There's a parabola opening down. I could use this picture. It's not exactly correct, though. When does this graph equal 3? Okay, so for example, here is the value 3, and I want to know when does it equal 3? Does it touch 2 times? No times? So what we'll do is we'll say 3 equals quadratic equation. Okay? Set f of x equal to number. Move all the terms to one side to make a 0. Since this leading coefficient is negative, I'm going to choose to move everybody to the left. I like to factor with positive leading coefficients. Minus 4x. I'm going to minus 9, but then there's a 3 there, so it's going to be minus 6. Make sure that you have equal to 0. I'm going to get a red pen, and I'm going to write, don't forget the equals 0. This is an equation. We're solving it. It has to have its equal sign, and it has to have the right side, which is nothing now. Okay, to factor this, I'm noticing that they're all even. If you can take out a constant, do that, and then your quadratic just gets a little smaller. Makes the factoring easier. Minus 2x minus 3 equals to 0. Okay, does this quadratic equation factor? Let's try. I know it would be x and x. And how do you make a 3? Well, it's got to be 3 and 1 to make a 3. And then one of them need to be negative to add to negative 2. Negative on the 3, positive on the 1. So we've got x equals 3 and x equals negative 1. When does this graph equal 3? At x equals 3 and x equals negative 1. Okay, I hope this Notecard summarizes all the different algebra things that we can do with quadratic equations. Thanks.